How you going, guys? Curtis from Cutting Edge Engineering. Today's job we have a 785 dump truck hoist barrel in for repair. What the hoist cylinders do on the dump trucks is they lift and lower the bin when they're dumping a load. There are two of them, one on each side. They are a two-stage telescopic cylinder and they are actually inverted so that they run upside down so dirt doesn't get trapped on top of the cylinder if it was in its standard configuration. So it's very uncommon for these to come in for any other repair other than an eye reclaim, but unfortunately this cylinder had an internal failure which led to the destruction of the inside of the barrel. There is a lot of scoring and gouges from where something has gotten inside there and it got trapped in between the piston of the first stage, and then it just tore the barrel apart as that cylinder was cycling. So what led to the failure of the cylinder barrel itself was the first stage of the telescopic cylinder. It had been reclaimed by somebody and they used a HVOF or HVAF, which is high velocity oxygen fuel, to spray on a new chrome layer after the chrome gets damaged. Well, it was a piece of that flaked off that started the failure. After a while, more and more of it falls off. It is a very, very hard material and it leads to what we have here today. So this cylinder at the moment is made up of two pieces. You have the barrel and the head flange, which are machined from one piece of hollow bar, and then the barrel eye, which is actually a cast item that has been welded onto the barrel. The ID of the barrel is 11.5 inches and the OD of the head flange is 15.5 inches. So this was a really big piece of hollow bar when this was made. When I'm done with this tube, it will be in three pieces. We will have the head flange, the barrel, and the barrel eye. So the first thing I need to do to get this set up in the lathe, I need to weld a square block onto the eye end of the barrel so I can then grab that with my 4-jaw tailstock chuck. I'll cut 2 steady bands on it so I can then support it, and then we will start to machine the barrel into its 3 separate pieces. So the barrel OD is a fraction over 13.5 inches, which is about 345 mil. A barrel that size would generally be done in our Shenyang machine because it has a much larger steady capacity. The steady that came with this machine is good for about 290 mil is about its maximum it can handle. But I was lucky enough to come across a 16 inch or a 400 mil steady rest that suited the bed of this lathe. So how I managed to come about this, I was up at a local machinery supplier and I noticed this sitting in the corner. I asked him what it was from and why they had it. It came from an equivalent size lathe, just a different brand, but everything was very, very similar. And I actually asked him, why did you have it and why didn't the people who bought the other lathe take it with them? And he said, because when they drove down the end of the street after they'd picked it up, the lathe fell off the truck and it rode it off. I got a steady rest nice and cheap and someone lost a very expensive lathe. So the reason I'm not going to use the Shenyang, I much prefer my Toolmaster machine. I'm very familiar with it, I've used it a lot, and now that I've got this big steady rest, any of those really large diameter barrels that I would generally do on the Shenyang, I can now do on my Toolmaster. So that's set up now. It's true enough that we can cut some steady bands and then we can start to take the cylinder apart. Normally when it comes to a barrel, we will try and match up an alignment mark with the barrel end to the head flange. On a cylinder like this, it doesn't actually make any difference at what orientation things are, because there is nothing up here that needs to be in alignment with anything. But even though it doesn't really matter, I'm still gonna do it because I like to put things back the way I found them, as standard as possible. We'll just quickly take a height from the lathe bed up to a point on the barrel end, as well as the head flange, and we'll mark them and then center spot them, so we can then line them up when we do the reassembly. Righto, so that worked out really well. There wasn't a great deal hanging onto that. I think it was more just the pressure of the tube after it had been welded. It would shrink a little bit, holding that barrel end in there because I had completely cut through. So a little bit of heat and it expands enough that the ends just fall out. So now that we've got that off, we can see all the little bits and pieces of the HVOF layer that have departed from the cylinder rod itself and been trapped down in the end of the barrel. Not only are there flakes in here, it has actually created a grinding paste. Generally, HVOF or HVAF is a very, very good procedure in order to repair a lot of chrome parts. If applied correctly, it can continually be reclaimed, so they grind it back, respray it, and grind it again. But in this case, it seems that the prep wasn't quite right, or it wasn't thick enough, or it hadn't quite bonded to the original strut rod. So now that that ends off, we can set it back up in the lathe and we can part off the head flange.
Oh, he could smell it.
From Brad G.
Thanks, Brad.
Oh, you get him. So we've got one more to open. I know who this is from, and I think I know what this is. So Matty from Matty's workshop made this. He has done an absolutely amazing job. This thing looks awesome. This is an oil can and it is used for your threading and cutting oils. It's designed so if you do tip it over, you don't spill out all your oil anywhere. He's actually got a video of making one of these oil cans on his channel. And he's also etched our company logo in it. And he also put an etching in the back, custom built by Matty's workshop. So Matty, thank you very much for that. That's going to go up on the shelf beside your oil can. Matty's also doing a giveaway. When he hits 10,000 subscribers, he's going to be giving one of these away to a lucky viewer. So if you want to be in for a chance, go check out his channel. Righto guys, so we've got the head flange off. We have our 3 separate pieces. Usually this piece of material would just go straight in the recycling bin, but I do have a upcoming something where this will be really handy. So we're going to put this one aside. Righto guys, so we're going to get the head flange prepped in order to attach it to our new piece of cylinder tube. Because the bolt holes that are in the head flange are so close to the ID of the finished barrel, if I was to machine that out and machine the tube down and slip that over the top, I would only have about a 9 to 10 mil wall thickness protruding through the head flange. That isn't enough in my opinion. One thing we need to take into account when we are building cylinders like these, this truck can carry 155 tonne of material, and 2 of these cylinders will then lift that bin to eject that material. So you don't want to have any weak points, whether it be the barrel, whether it be you've machined too close to the bolt holes, or the wall thickness of the tube isn't enough to support such a load above it. So what I need to do with the head flange, I need to bore it out about 2 mil oversize. I then need to weld prep the ID and the OD so I can then attach it to the new barrel with 100% penetration weld. And because I've bored this out, I can then build that up with weld. I can re-bore it to size on the lathe, and then I can hone the 2 together. So that will be the closest way to get this cylinder back to its standard configuration. Something I like to do when I'm trying to get 100% penetration weld, I will prep the ID as well. I like to use a button insert for doing the weld prep on the inside. Not only does it leave a nice round edge so you can actually see down inside your weld joint when you're trying to do 100% penetration, they're also very versatile in the way that you can use them for doing these sort of jobs. Generally, when the tool is on center line, you will not get them down the inside of a head flange or anything like that. So what I do is I will lift the tool above center height, about 30 mil. That way I've got clearance for the bottom of the tool to actually get down inside a job on its ID. The reason I do the ID is so I can get a nice decent weld on the inside. By back grinding the weld from the outside, I can then get into the weld that's on the inside and know I'm going to get 100% penetration weld. So that's the head flange prepped. It's ready for weld now, so we're going to take this out of the machine and set up the barrel. We've got our new piece of barrel material set up in the lathe. The barrel material is an unhoned tube, which means it has 1 mil to come out of the ID to clean up to 11.5 inches. The OD of the barrel material is 14 inches. The standard size is a fraction over 13.5 inches. It is not available. It's not a size carried by our suppliers. So we will end up turning the OD down to match up with the standard barrel. So what I need to do now, I need to cut 2 steady bands on the barrel, and then I need to prep it ready to take the head flange. Righto guys, so that's all the welding complete on this end of the barrel. We're gonna have to let this cool down now, so stay tuned for part 2 where we finish off the barrel. Thanks for watching. How you going guys? Curtis from Cutting Edge Engineering. Today's job we have a 785 hoist barrel in for a rebarrel. Am I saying righto? Or so? Righto guys, so we've got our new piece of Barry. Who's Barry?
Hey Barry.
So the reason they run them upside down, oh fuck, I just bit my lip. Fuck me. The ID of this tube is 11.5 inches and the OD, unfortunately, that material is not available, so we aren't going to be making out a hollow bar. We will be, we'll talk about that later. Should we talk about that later? Any of those really fat barrels that are, oh, should I say fat? Fuck, that sounded bad. Oh fuck, no shit. So, don't leave your foot under them, and don't have a camera girl under them. So it gets taken out. Oh, Yummy. Oh, there's a chunky bit. That's part of the barrel.
Oh my god.
Fucking uncomfortable as shit. Super uncomfortable. Which I am not. This is gonna be fucked. I'm gonna go, what are you on the floor for? Let's put this sleep.
No. Hey, stop. No, oi, sit. Just wait. Oh my god, he killed it.
Really?
Yes! In 2 seconds. Poor little piggy. He could smell them. Oh look Dad, look what I got you. Where's the other ones? They're dead.
You get him.
No, hang on, there was more.
No.